Hello, this is Mrs. Slater, and today we're going to start Chapter 5, which is on polynomials and polynomial equations. So in the first section, we learn all about what a polynomial is and a lot of definitions. So the first one is polynomial, and that's a general term for all of the things we're going to be learning about in this chapter. And then if you divide polynomials up, what it actually is, a polynomial is made up of different sizes. So you have different types of polynomials, and then the first one is going to be a monomial. Mono meaning one, so there's going to be one term, and it's a number, or it could be a variable, or it could be a product of a number and variable. So some examples that you may see in some of your work is the number 7. That is a monomial. Or maybe negative 4x. That right there is a monomial. And then another one that you can see is x cubed y. That would be considered a product of a number and variables. Okay, the next one is a binomial. Binomial is going to be the sum or difference of two monomials, so it's going to be looking something like this, where you have to add or subtract. So x plus 7 would be an example of a binomial, meaning 2. And maybe 2x minus 14. That is another binomial, because there are two terms, and it's separated by a plus or minus sign. The next one is a trinomial. A trinomial is the sum or difference of 3 monomials, and one example of that is x squared plus 8x minus 4. 3 different terms, and then separated by a plus or minus sign. And then the last one is very general, where you would have an nth term polynomial. So if I gave you something like x to the 4th plus 3x squared third plus 4x squared plus 5x minus 1, that is a 4th term polynomial, because it's the sum or difference of 4 or more monomials. So each one of these is a monomial separated by a plus or minus sign. Okay, so let's go on to what a degree is. A degree of a monomial is the sum of the exponents of the variables. So in this particular one, 7, if you look at where the exponents are, there are no exponents. So any number or any constant by itself is going to have a degree of 0. Okay, and then also negative 4x, since there is one variable and then there's the invisible one that you see here, that's going to have a degree of 1. And then x cubed y, okay, again we have the invisible 1. And then you would actually find the degree by adding the two together. So for this one, the degree is going to equal 4. Okay, so if we're going to find the degree of a larger polynomial, you have to take the highest degree of all the terms. So individually, you have x cubed plus 7x minus 8. So, like I said, individually, what is the degree? This one is 3, this one is 1, and this one is 0. So you take the highest out of all of them, which is 3, and then that ends up being the degree. So the degree of this polynomial then is of 3. Okay, let's try another one. This one I'm going to make as 5x squared minus x cubed y to the 4th plus 13x minus 1. So individually, this one is 2. Looking at only the exponents and adding them together. This one is 1, this one is 0. So what I'm going to have to do is take the highest, which is 7, and call it a degree of 7. Okay, so that concludes all of my definitions. Now let's do some practice. First thing I want you to practice are finding function values. Okay, this is not unfamiliar because we have practiced on this with lower problems or lower degree problems. What we're going to do in this section is take a polynomial. For example, p of x equals 2 x cubed minus 3x squared plus 6. And we are going to find the function values of p sub 1. Let's try p4. And the last one, p negative 2. So when you are trying to find a function value, everywhere you see an x, as you can see here, this is getting replaced with, the x is getting replaced with 1. So everywhere you see in the function or the polynomial, you're going to put a 1 in that spot. And then do the math, so that ends up being 2 minus 3, which is negative 1, and then plus 6 gives you 5. So that is the answer there. And then the next one, you'd want to plug a 4 in everywhere you see an x. 4 cubed minus 3, and then 4 squared plus 6. Find out what that answer is. And then the last one, negative sign, be careful, just use those parentheses, that will help distinguish between what is going to be a positive answer and what's going to be a negative answer. So go ahead and push pause and get your calculator out and solve those two function values. Okay, so if you got 86 for the first one or the second one and negative 22 for the third one, you are correct. Below I have how I plugged it into the calculator, so that will be a quick check if you did get something different than I did. And let's go ahead and have a few practice problems. So if your original polynomial, I want you to do this on your own, and we'll talk about it tomorrow in class. P of x, if you have 2 and then x squared plus 3x to the 4th minus 10, I want you to find two things for me, p of 2 and p of negative 3. Okay, good luck with those. And now let's talk about combining like terms. Alright, so when you combine like terms, you should always look for the same variable with the same exponent. Okay, so that's what that means, same variable and same exponents means that you can add or subtract them together. Okay, so for example, if you are going to combine like terms to 5x squared plus 3x to the 4th minus 2x squared minus x to the 4th, I would use different colors or underlining or squares around each one of them that are exactly the same. And I can see that here in blue is the exact same thing as negative 2x squared. So notice I'm always going to take the sign to the left, use sign to left of term. Okay, and when you are circling it, that may help to put those together. So I'm going to put those two together because they are exactly the same. And then the second one and the fourth term are also the same. So I'm going to take those and put them together as well. So when I add like terms, combine like terms, 5, I only look at the coefficient. 5 minus 2 is 3. So then the variable with the exponent is going to tag along as part of the answer. And then also on this one, both of them x to the 4th, invisible 1, 3 minus 1 is 2, 2x to the 4th. Okay, so then if you look at the final answer, you'll see that the higher degree, this one right here has a degree of 2, and this one has a degree of 4. So, and to be a formal answer, you would take the highest degree and put the answer in decreasing order. So you will see this a lot when you are checking your answers, where the highest degree is going to come first and then it goes in decreasing order. So that would be your final answer. Okay, so let's try another one. Example 2 is 5x squared y squared minus 2x squared y cubed plus 4x squared y squared. Okay, so look for like terms, same variables, same exponents. So those are the only two that can go together. Yes, the x squared is the same, but it has to be the whole entire term that has to be the same. So I'm going to put those two together and I'm going to combine all of the like terms. The negative 2x squared y cubed, there is nothing to combine it with, so that's just going to be part of the answer. And this will be 9x squared y squared, because you take the coefficients and add them together, and then minus 2x squared y cubed for the final answer. And actually, before I say final answer, I should look at the degree. This degree is 4. This is a degree of 5. So we should put it from least to greatest. So 2x squared y cubed, it would be a negative, plus 9x squared y squared if we're going to put that in degree order. Okay, and then the last one, I'm going to have you practice, and then we can also discuss that one in class. Combine the like terms of this example. 3xy squared minus 4x squared y plus 4xy squared plus 2x squared y plus 3x squared minus y squared plus 2x squared y. All right, good luck with that one, and I will answer all your questions tomorrow.